Hi guys, just wanted to check in. Let's do week 4 Friday problems. For problem number 7, they gave you that f of t was equal to 80 minus 10 cosine of pi times t over 12. And t is less than or equal to 0, or less than or equal to 12, but greater than or equal to 0. And the sketch was just worth 1 point. So if you got that correct, great. Okay. For part B, the average, so average value needed to be 1 over that 14 minus 6 times the integral from 6 to 14 of f of t. And you could just write f of t dt, okay? And please do not do this by hand, okay? So average value is this, okay? Go do that with your calculator, and you end up with 87.161 or 162, okay? But it said nearest degree. They do take points off for that. So which is approximately 87 degrees Fahrenheit. And that's what they were looking for. Okay, for part C, it says an air conditioner cooled the house whenever the outside temperature was at or above 78 degrees. So what we needed to see is this function, 80 minus 10 cosine t, cosine of pi t over 12, okay, is greater than or equal to 78. Okay, if you solved that it was equal to 78, that was fine, but you have to figure out that that is the range, okay, that that is above 78 degrees, that's when it's running. Well, when you solve this, you get that you've got two values, right? So you want to know when you solve this that t has to be in between these two values. And again, you're using your calculator, okay, 5.231 or 18.770, okay, and those were hours. So once you do that, you solve that, you get those two values. This is what we're looking for, okay? Or some of you wrote, and if you chose parentheses, I took points off because you have to understand that it goes to being equal, okay? We're including those endpoints as well, okay? That was worth 2 points. And then the last but not least was asking the cost of cooling the house that accumulates at a rate of 0.05, so a nickel per hour for each degree the outside temperature cools. So if you look back at your graph looks something like this. And if you put 78 degrees on there and draw a horizontal line, what we're looking for, and where you just found was 5.231. This is where it equals, and this is 18.770. This is where it equals 78 degrees, okay? We're looking for this area up above, okay? So we want to get the accumulation. If we want to get that area, when it says accumulate, that means area, okay? So when you're looking for that area, what we're going to do is we are going to get the integral, right, of from 5.231, 18.770 of our function, but then we're going to take off 78. So it's going to end up being 80 minus 10 cosine of pi t over 12 minus the 78. Okay, because we're going to take the 78 that's below it off if we get the area. So the accumulation means area, okay, or total, or add all of that up. Okay, but now they wanted you to get the cost, and the cost is going to be that nickel times, okay, all that time. All right. and that was worth 3 points. Okay, then if we go to problem 8, problem 8 asks you to evaluate. 8 asks you to evaluate the integral from 0 to 1.5 of 3f prime of x plus 4, okay? And then this is dx. Okay, when you're doing this, integrate. So if I have the derivative here, right? If I take the integral of the derivative, I should get the original function. So that should be 3f of x plus 4x evaluated from 0 to 1.5. So that's when you're going to go and plug in 3 times f of 1.5 plus 4 times 1.5 minus parentheses 3 times f of 0 plus 4 times 0, which I know you know. Okay, so just kind of keep that in mind and you can go get that. So some people did not get that. Part B says, that was 2 points, getting the antiderivative and then the answer. Part B says write the equation of the tangent line at the point where x equals 1. Well, where x equals 1, that's the point 1, comma, negative 4, okay? And the derivative there is 5, so I should say f prime of 1 is equal to 5. So that's the slope. So y plus 4 is equal to 5 times x minus 1. I'm not quite sure why people put 1/5. Okay. Now, they're asking you to approximate f of 1.2. This is your linear. Okay. They said write an equation of a tangent line. Okay. And then use this line to approximate f of 1.2. I need to see f of 1.2 is equal to 5 times 1. Approximately, okay, because it says approximate. Use it to approximate. 5 times 1.2, whoops, minus 1, and then minus 4. So I have 5 times 0.2 minus 4, right? So then we end up getting that it is negative 3. So f of 1.2 is approximately negative 3. If you just came up here and substituted 1.2 in there, I did not give you the credit for approximation and just getting negative 3. You have to understand that you're using the tangent line to approximate. Then it asks, is the approximation greater or less than the actual value? And that has everything to do with the fact that it's concavity. So approximation is less. Now, some of you told me, you said that it was less because of increasing, okay? We're gonna go with a concavity because right now, okay, we are concave up on that interval, and here's your approximation. Yes, you're increasing, okay, and so that's how I know that this approximation is below the actual function, but increasing doesn't work all the time. If I'm increasing like this, you can see that my approximation would be above the actual function. Okay, so it would be over. All right, so it has to do with the fact that the concavity. So make a note of that when they ask, is it an underestimate or is it an overestimate, we're going to say that this is under because it is concave up. So concavity determines not whether or not it's increasing or decreasing. Okay. All right, then part C says find the real positive number R having the property that there must exist a C that lives between, so C has to be living between 0 and 0.5, and F double prime of C is equal to R, okay? If you are looking at any kind of guarantee, okay, you have to think mean value theorem. Okay, so what they're saying is that f double prime of c better be, so that's the slope of the, or I should say that is the second derivative value, the instantaneous rate or instantaneous value rate of change of the second derivative, actually the first derivative is instant rate of change, okay? So then we're gonna go and say, okay, well, what's the slope f prime of 0.5 minus f prime of 0 over that 0.5 minus 0, okay? And you're gonna get, what is that R value? Okay, so mean value theorem. If you did not mention mean value theorem, you did not get any points, okay? If you got R was 6, but you needed to get that extra point by putting mean value theorem, okay? But if they're asking for a guaranteed value of a first derivative, a second derivative, any kind of derivative, you've got to start thinking about mean value theorem, okay? And last but not least, on problem D, they're telling you that g of x is equal to 2x squared minus x minus 7 for x is less than 0. And then they're saying that that's 2x squared plus x minus 7 for x is greater than or equal to 0. And it says the graph g passes through each of the points of f that's given in the table above. Is it possible that f and g are the same function? Give reasons for your answer. Well, I'm going to take the derivative. So G prime here is 4x minus 1 at x is less than 0, and it's 4x plus 1 when x is greater than 0. Notice I'm not putting equal to. However, some of you did use that, okay? But right now, the reason why I'm saying that at zero, when I plug in 0, I'm going to get two different answers. So I do not actually have a derivative at x equals 0 for g, and that's not the case. So f prime of 0 is equal to 0, and there is no such derivative, okay, for g. Okay, so f can't be g. All right, done. I will do test corrections in a little bit.